Hi everyone. See, in the last session, we have completed the stack program. But see, in the last class, everything we defined inside the main only, and the code also, we defined here directly. But today, everything we are defining, in the form of methods. So normally, how the stack will be, how the functionality will be, everything one by one, I'll explain. From the same logic only we will do. But see, here we are taking that new class. Class name I'm taking stack operations. Stack operations is the class. Here we are taking the class. Sir, what is the class name? Class name is a stack. Already with the name stack predefined class is there, but no need. Don't consider. I'm creating one class name is a stack. Because any operation you want to perform, just here, everything is inside this class. Sir, what is the stack functionality? What is the stack functionality? There is a method called push method. First, static methods I will explain. Push method, it is taking the element and it will push element onto the stack. Next one is static methods we define as a public. And this method is also public. Public static, pop is there. It will return the top element. It will return the top element. So what is the element? That element it will return. Int pop. Because here integer stack we are taking. Next one is a peak. Public static. Peak element it will return. Peak element. Next one is whenever you are pushing the element onto the stack, checking that stack is full or not. If it is full, you cannot push element onto the stack. Is full. Return type is Boolean. Return type is Boolean. Next one is empty. Is checking is empty. Last one is traverse. All are initially static methods. Slowly, I will just make it instance methods. Static, public static void, traverse. Void, traverse. That's it. So we are creating one class. Class name is a stack. Stack is having this much functionality. That is, sir, how can we perform all operations? Same story from the main. From the main, how? I'm creating that stack with the particular size and top. Stack name I'm giving STK. No confusion. Because actually here class name I'm taking stack. And this is STK I have taken. Just one stack. Same operations, while loop. While loop, one is for peak. One is for peak. All these things. Let me explain. Now we are doing one by one. Enter your choice. Enter your choice. If the choice is equals to 1, If choice is equals to 1, what we have to do? Else if choice is equal to 2, what we have to do? Else if choice is equals to 3, what we have to do? For all the things, else if choice is equals to 5, else, like this. All we are writing, if, else if, else if, else if, else if, else, like this. First one, if the choice is equals to 1, yes, if choice is equals to 1, push the element onto the stack. Scanner object we are creating equal to new scanner of system.in. So we are importing import java.util.scanner. Java.util.scanner. That is the choice. We are collecting. If choice is equals to 1, we ask them to enter the element to push. Enter element to push. Same code only, but small modifications. This is the real one. Element we are collecting. Next, what we have to do? Once you collect the element, then you have to call this function push, which is belongs to the stack, and you have to pass that element onto the stack. So what will happen? Stack. Okay. Here it is. Here it is. Static method. How you will call static method? We know already using the class name. So simply stack dot push, passing that element. So that work is done. So control will come to here. And here what we have to do? Directly we are not pushing. First we are checking if the stack is full, or you can call stack dot is full. If stack is full, then we can say that stack is full. System.out.println stack is full. See, from one function you are calling another function. You are calling stack.isFull function. We are calling this one. It is responsible. If stack is full, it will return true. If not, it will return false. Where is the code for stack is full? We have already this. If stack is full, that code we have to write here. If stack is full, it will return true. Else, it will return false. IsFull method is responsible for checking that stack is full or not. If stack is full, it will return true. Now stack is not full. Suppose initially it will return false. So the true or false will come to here. Suppose if it is returning true, it is say that yes, stack is full. If not, stack is not full. If stack is not full, then we can push element onto the stack. How to push? Push code is the same code. This one on ++ stop. After that, element. What you have passed to the method that you are storing into the top, and then saying that element is pushed. This is the first code. Is the first one. Second one, ch is equals to 2. Choice is what? Pop. So no need to read anything whenever you are deleting element from the stack. Directly pop you can call. But look at this. Pop is returning. What is the element will pop? On success, it will return element. If element is there, it will pop, else it returns -1. Consider. Here, I'm just giving that return deleted element or popped item, else -1. Just for understandability sake, what it is doing. So whenever you are calling pop here, stack.pop, stack.pop, that is. Okay. Simply here, it will come to this stack.pop. What it is doing? What it is doing? Before deleting, checking that pop, it is checking stack is empty or not. If stack is empty, directly it will return -1 because no element na. But sir, where is the code for stack is empty? How you have written the code for stack is full? In the same way, you have to write the code for stack is empty. The code is already with you. Empty stack is a top equals to -1. If top equals to -1, it will return true, else it will return false. It will return false. So here it is returning like this. The first one, if stack is empty, it will return -1. Return type is integer. So -1 is returning back to here. That we are collecting here. That result. No, sir. Right? If stack is not empty, then what it will return? This is important. Stack of top element it will return. Top element it will return. After that, minus. Top should decrease now. Top should decrease. Stack of top element will return. After returning, top value will decrease by 1. So top minus. Top element will return. Whatever the element will collect here. But here how it will decide, look at this. If result equals to -1, stack is empty. Sir, why you are writing here? In a simple way also, we can write. In a simple way. Here only directly you are checking. Stack dot is empty. If stack dot is empty, you can write. But actually rule is what? Everything you need to define here only. Inside the stack only. Inside the stack. This is the one. Okay. See, lastly, I'll explain a very important one. A system dot out dot println stack is empty. If no elements, it will return -1. Else, that element, popped element is what it is returning, that we are printing. If it is -1, we are not printing. If it is other than -1, something like 20, 30, 50 or something, we are printing that result. That is. The next one is, what is the third one? Third one is a peak. Peak is also same story. Peak is also same story, but only the difference is what? Only the difference is what? You know that. Just minus minus we should remove. It will just return the top one if stack is not empty. So same code here, copy paste. Same code, just peak. Peak. If result equals to -1, that is. Else peak element is that result printing. That result. Okay. Next one is a traverse. Which one? Here it is. Invalid choice. Invalid choice. Next one, exit. End of stack operations. Just break. If it is the last one, directly traverse way we are executing. Traverse. How? Stack. Stack dot traverse. Stack dot traverse. Then in the traverse also, first what we are doing? First we are checking if stack is empty or not. If stack is empty or not. If stack is empty, directly we can say that message is an empty stack. If stack is not empty, we are displaying the stack elements. You know how to display. All the stack elements we are displaying. All the stack elements from top to 0. This one. But here, one very important thing is what? Everything is okay. We have converted everything into that class, methods, everything perfectly we designed. But one part is, stack is a local variable in main. Stack is a local variable in main. That is. Then how can you access here? In another class, how can you access all these things? No. That stack is also, you have to create inside this one only, but as a static variable. All are what? Static. So available everywhere. Sir, normally how can we access static, sir? Static variables we are accessing using the class name. From outside, if you want to access, we are using, but outside we never use. Na? Inside the class only we are using. No, sir, still I want to follow the rules, sir. Okay. Stack dot size. Wherever you are using, here it is a ++ top. How to do? Stack dot ++ top. Everywhere, sir, I want to do like this. I want to do like this. STK, na? Sorry. STK. No issues, no issues. Sir, everywhere, because static variables, even though you are not following the rule, it will work out. No, sir, I will follow stack dot. Same class. If you are confusing, no need to follow. I'll show you. Stack of top, stack of size, stack of top, stack of top, like this. See, within the class, whenever you make it available in all methods, define all variables as a static variables. Simply we can access directly within the class. No, sir. Normally Java rule and .NET rule is what? Whenever you define variable as a static variable, we are accessing normally using the class name. Normally using the either static method, static variable. So we are following the same thing. When you are executing the code, stack dot plus plus top, stack dot plus plus top. In that one, in that line number 69, in that line number 69, stack dot it is saying, na? That's why it is expecting. Stack top. That is only the problem. We can do actually. Whenever we are doing this, executing the code, we keep on inserting the data. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now again 60. No, how can you insert 5 elements already inserted? So stack is full. I just want to traverse. See 50, 40, 30, 20, 10. Peak element is 50. Pop element is 50 deleted, 40 deleted, 30 deleted, 20 deleted, 10 deleted. Again delete? No, stack is empty. How can you delete? How can you traverse empty stack? So exit like this. So everything we are just converting into the methods and separate class. Methods and separate class. Within the class, whenever you are using variables and methods, see everywhere stack like this is enabled now. You can remove all these things also, program will work. But I'm not removing actually, I'm saying because within the class you can access static members directly. But according to the Java rule, static members we are accessing using the class name, Java rule and .NET rule. This yellow color stack everywhere you remove, still the code works same. Only thing is what in the last session, I have explained everything without using the classes and separate methods. But whenever you check that in Java library or .NET library stack class, the class will be like this only. The class will be like this only. Simple. Got it? This is the one. Sir, one more option is there. How can you decide like this, sir? I just want to create that stack with my own size, sir. How you decide this file? Hope you got the point now. Right. I will create the stack with my own size. Happy. I'm taking one variable size. I'm not creating this. Got it? I'm taking the top equals to -1. These two, okay. Size and top equals to -1. This way also you have to try for today. Now, I'm taking one method, public static void create that stack with the size. With the size. This one. Here, in the beginning, whenever you are writing this, first system.out.print, enter initial size of the stack or enter size of the stack. enter size of the stack. Int n is equal to, please don't write this in while loop. Sir, why? Once a stack is ready, then we perform the stack operations. Creating stack is not the stack operation. So first of all, stack dot create and passing the n value. Passing this n value, stack dot create. Create stack or create, simply create. Now here what we are doing, stk equal to new integer of that n. That n only you are assigning to size also, because for everywhere we are using. Stack is ready. Stack is ready. Then you can perform the operations. Now look at this, how this code gets executed. How this code gets executed. Enter size of the stack, 3 only. Stack is ready. Now look at this, you can push elements 10, 20, 30. Now 1, impossible. Reason is what? Size is 3 only. So stack is already full. Stack is already full. Exit. This is how we are creating the stack. Every time we are write only operations from another class. Stack we define separately. Stack we define separately. So everyone, today you keep on practice with this, because whenever I explained Q in tomorrow class, in the same way you have to implement without class and methods, and with the class and methods also you have to import. Okay, I'll share this in the group. Everyone please check. Along with the last video, this video also I'll upload.